Welcome to this video in which I'm going to recap 10 things that you should know about R and RStudio to be well set for the remainder of this course. So firstly, how do all the different pieces fit together? I think it can actually help to think about it in terms of a smartphone analogy, where R is the processor and the operating system that's mostly running under the hood. On top of that, we have RStudio as the user interface, and in RStudio there are a couple of pieces that are really helpful and many pieces that are completely irrelevant for the work that we are going to do. The really helpful bits are the console to interact with R, the file editor to edit scripts like the R Markdown files, the environment to see the variables that we have, and finally the history that allows you to go back to commands you have run earlier so that you don't need to type them again but can just copy them back. Finally, what makes R really powerful are all the packages that you can think of like apps that you install on a smartphone. They've made it one of the most widely used and most powerful programming environments and statistical software packages out there. They're installed once, like you would an app. They need to be loaded in every session. So basically they need to be opened once so that you can access them later on. Very briefly, switching over to RStudio to just show the bits and pieces. Down here we have the console. That's where you can interact directly with R and where R gives you its output. Here at the start, R tells you the version you're running, basically says hello to you. Later on you can type any commands in here and you get the results right there. Up here in the file editor, you can edit the Markdown documents. We'll get to that in a second. In the environment, you can see any variables. Currently mine has none. If I save one down here, I can now see there's this value in my environment. And finally, the history is full of commands you have run in the past that you can search and then reuse. Down here, actually, the help pane is very helpful to get information on functions. We'll get to that in a second. Back to the presentation. Next point I want to emphasize are the R Markdown documents, because we want to work towards reproducible analysis. We don't want to be typing the same code again and again. We rather want to type the code once and then be able to generate reports. And for that we need to use these scripts. They can either be standalone scripts where you only have R code, or they can be these Markdown documents. That's what we're using in this course, because they also allow us to add text and to have separate chunks of code. In those documents, gray chunks that are highlighted in gray, they are code. There you should write all the commands you want R to run. Anything else is not executed. It's just formatted. And for that we have these markup symbols that allow for easy formatting. It's not a focus in this course and we're going to get to it later, but with those you can easily add headings and just make the text look nice. But only things in the gray chunks are executed and run by R. Our Markdown documents, they are where our production code should be. Next point, what about data and variables in R? The most important thing to remember is the assignment operator, which is this less than minus. So this operator takes any value and saves it in a variable with a given name. Variable names are case sensitive, so make sure you use lower and uppercase consistently. If you want to save more than one value into the same variable, the C function is helpful, because that allows us now to chain value 1 and value 2 together and save it again in this name using the assignment operator. Quite often we are interested in many variables at once, and then we use data frames that are basically just tables. Within them we use the $sign to access specific variables. So you can look at many examples of this. In the gapminder dataset we might write gapminder $GDP to access the gross-domestic product variable in the Gapminder data frame. And for types of variables, for variable classes, as R calls them, numeric, character, logical, and factor, R generally deals with them correctly. If something goes wrong, it's worth checking whether your variable actually has the correct type. Next, functions. Functions in R are basically any of the commands where you tell R to do something. They all have a name, but then to tell R that you want it to be executed, that it is a function, you need the brackets behind it. So the simplest ones are functions like timestamp that just prints out the current time without anything else. Name timestamp, brackets, tell R, run this function. Usually we want functions to do something with specific data, and that we give as arguments by putting it into the brackets. So the print function prints something out. Clearly we need to tell it what to print out, so we give the value of hello in brackets. The other thing we can do with arguments is to provide additional instructions. So in the mean function, we would first provide data, the numbers that we want the average for, and then we can say na.rm, which means remove missing values. We can set it to true. That now means the mean function will first delete missing values, then calculate the mean. So those arguments are instructions for how the function should run. It's helpful to check the help by typing question mark and then the function name to see what arguments a function is going to be using. Arguments in a function can be identified by the order in which you give them, and they can be identified by the name. Named arguments are always matched first, and then all the remaining arguments are matched by their order. So in the mean function, further up, nr.rm is matched first because it's named, then data is matched because it's then in the first place. Generally, I'd highly encourage you to name all your arguments apart from the data. It just makes it much easier to read your code and much less likely to make mistakes. To save the results of a function, again we use the assignment operator that then runs the function and saves the value that comes out in a variable. Of course, if you just want it to be printed, you don't need to assign it. R on its own is quite powerful, but then by adding additional packages, we can simplify our lives and do things that we couldn't do without them. In this course, we're very heavily using the tidyverse. It's loaded with the library tidyverse command, and just contains a bunch of packages that make working with data more efficient and somewhat more intuitive. The first one is dplyr. That's all about data manipulation and calculating descriptive statistics. The second is ggplot2, which is the best package for creating graphs of all kinds. Then we have reader, where we can load tabular data into R, particularly CSV files that are one of the most common file formats for sharing data. And then there are a couple of other packages in the tidyverse that still need to be added, that still need to be loaded separately. So if you want to use them, you need to run the library command, the library function with the package name. The most relevant ones here are readxl and Haven, two packages that allow us to open other data, and I'm going to get to that a bit later in this video. And then there are the stringr and loopredate packages that allow us to deal with text and dates in rather straightforward ways. So those 7 packages actually, they give us really a very powerful set of tools in R. Starting with dplyr, that is the tool we use for data manipulation. The main contribution is this pipe operator, so it's important to understand that properly. The pipe operator allows us to chain many different simple actions together rather than to build really complicated nested functions. For that, it just takes the value that we have on the left into the function on the right as the first argument. So this rather trivial example would take the value of hello, put it into the print function as the first argument. Clearly no need to do that. But it is very helpful when you then have some more steps and some more arguments. Then the functions in dplyr, they're natural language verbs. Sometimes R functions have rather strange names. dplyr tries to do away with that and have very clear function names. The most important ones are select, which unsurprisingly selects specific variables, filter, where we can filter rows, arrange, where we can sort data, and the default is small to large, so we need the desc function for descending if we want to reverse that ordering. Mutate changes variables or creates new variables. Summarizes data by calculating summary statistics. And then group by is very helpful to separate the data into groups to then summarize it. For example, to separate Gapminder data into continents. All of these functions use a data frame, they work on a data frame, and then you can just refer to the variables without the $sign. And because they use a data frame, the pipe operator is really helpful. So we would take a data frame, give it to, for example, the select function. The select function will return the data frame. With the pipe operator, we can give it to the next function. So, and thereby just build a stepwise chain of commands. If you read the pipe operator as then, you can understand the sequence quite well. It occurs you to have a look at the document associated with this and try to follow the example yourself. I'm just going to show it briefly here. So if I'm trying to get the average income per capita in each continent, I need to do quite a few steps. If I now read them as take Gapminder, then filter for the year equals 2010, then mutate, create this new variable, then filter again to filter out missing values, then group by continent, then summarize, and then arrange descendingly. And do have a look at the code, see if you can understand the code. But basically, by having these natural language verbs as functions, and by having the pipe operator that means then, you can write code that other people can read and that you can understand yourself. Then much about dplyr. Dplyr is powerful in combination with functions to view and summarize data. So if you have a new data set, you first might just want to have a look at it. The easiest thing is to type view into the console, view with the name of the data set, to open it up. Then you can really have a look at what it looks like. Glimpse is a function that gives you a summary of the data set and again shows some of the data. Head and tail are functions to show the first few and the last few lines in your data set. This is helpful to run some of these functions, have a look at the data, to figure out what variables do I actually have, what class do these variables have, how many observations. So those are the first few steps when you work with new data. Then we might want to describe the data with some summary functions. One might just be the sum function to add up all the values. You have the n row and the n function for the number of rows. Have a look at the accompanying document again to see the difference between the two. You have the mean function that simply is the sum over the number of observations. The median function to find the value in the middle of your distribution, where half of the observations are smaller and half are larger. max and min. And most of these, except the nr.rm argument to remove missing values. If you don't set that, and you have missing values, and you try to calculate the sum or the mean, for example, you will get an error message. After you've done some, just looking at the data, calculated some descriptive statistics maybe, it's worth creating some graphs. And for that, ggplot2 is the most powerful tool. It follows this idea of a grammar of graphics, and like a sentence needs a couple of kind of compulsory elements. Any graph needs these three compulsory elements. It needs data, it needs aesthetics, and aesthetics are the mapping of variables onto visual elements, and it needs geometries, which are basically chart types. So for a simple graph, I need to call the ggplot function. I need to provide data as the first argument. That in this case is the gamma in the data set. I need to provide an aesthetics function as the second argument. And this aesthetics function, I'm now mapping variables onto visual elements. So I'm mapping the year onto the x-axis, life expectancy onto the y-axis, continent onto color. Now I need to close both the AES function and the ggplot function, so two closing variables. And then I can add one or multiple geometries. Here I'm just adding geom_point for a scatter plot. What are common aesthetics? Most frequently used, clearly x and y for the axis, color, fill, size, and shape, usually for categorical variables. And then the most common geometries would be a histogram to see the distribution of a variable, a box plot also to see a distribution, but actually with less information, but more comparable across many categories. geom_point, a scatter plot, to see an association between two variables, to see whether there is an association. And then geom_smooth is to draw a line of best fit, which helps with quantifying the association. That takes us into the realm of inferential statistics. We're going to discuss that more in the weeks to come. To do all these fun things with data, we need to get the data into R. And R is not good for data entry. So the recommendation always is to create a data file in Excel, in some other spreadsheet program, Google Sheets, wherever you want to, but in a place that's good for data entry and that's separate from your analysis. Or of course to download the data from some online repository if you analyze someone else's data, and then to read it from that file into R. If you've loaded the tidyverse, you can use the reader functions like read_csv, provide the file name to it, it reads the data, it saves it. For that, the file needs to be in the same folder as your IMD file, or you need to specify where it is. CSV files are comma-separated values, so they are tables saved as plain text. And you can save it as that in Excel, you can download it as that from Google Sheets. If you then load additionally the read Excel package or the Haven package, you also have the read_Excel and the read SAV function. Read TSV loads tab separated values, very similar to CSV files. Basically just a different character that separates the values. And that should always be what you do in production code. If you're just trying things out, there are some quick and dirty alternatives to just get some data into R. The easiest might be the edit function. If you run it like this, just providing an empty data frame to it, it opens up a simple spreadsheet. You can define your variables, you can type in your data. It's a quick way to just get a bit of test data into R. One other way is to read your data from the clipboard. So you can copy data in Excel and use this to read it into R. clearly that only makes sense for a quick test. If this is your real analysis, you would always want to use the read Excel or the read CSV function because it's replicable and more robust. If in what you have copied, the first line contains the variable names, you can add the header equals true argument so that your variables are actually named. Otherwise, the variable names are auto-generated and thus won't have any information about what the data is about. So these are the ways to get your data into R. Coding in R, like writing any script, to some extent is always about trial and error because small problems will occur all the time, and then it's about figuring out why things don't work as they should work. First thing to note is that red text is not always an issue. Some of you have been worried about that in class. When you load packages, when you create charts, you quite often get a lot of red text. If it specifically says it's an error, then it needs to be fixed, because when there's an error, R stops executing your code, so you won't be able to move on or create your knitted file. So those need to be fixed. They're not always super clear. Sometimes they tell you what to do, sometimes they just tell you that something is wrong. If they don't tell you what to do, try to reread your code and then maybe Google the error message, and then you'll eventually find out what has gone wrong. Warnings, on the other hand, are often not a problem. So, for example, often we know that some data is missing. If we then plot that data in ggplot, ggplot warns us that data is missing. If we know that in advance, clearly there's no problem. Still read them. Sometimes they do alert you to problems you aren't aware of, but no need to freak out when you get warnings. There's a lot of other red text that literally is just information for you. No need to worry about that. Unless there is an error, it's quite likely that you're on the right track. The most common mistakes that cause trouble are missing brackets, because when you layer a couple of functions on top of each other, you end up with quite a few brackets, and then you need to make sure that each opening bracket is matched by a closing bracket in the right place. To figure out if it is in the right place, you can move your cursor to the closing bracket, and RStudio will highlight which opening bracket it is matched to. That's worth doing to see whether they're actually in the right place. Misspellings are a very common problem. If you save your data into a variable that's spelled wrong, then clearly the variable that's spelled right won't have the correct data later on. If you misspell a function, R won't find it. So watch out for that. And the most common thing that can go wrong there is capitalization. So try to be very clear when you want to use capital letters. If R tells you that it could not find a function, usually it means that the package is not loaded. So then load the package by running library with the name of the package. And really don't try to remember everything. What's important is to understand basically the things that I covered in this video, to understand them conceptually. But even here, for example, you don't need to know the names of all the dplyr functions. It's about knowing what's going on and then about knowing where to look. First place where you will look a lot is in the help of specific functions. To get there, you type a question mark in the name of the function into the R console. It opens up the help, and that help, for example, tells you which argument the function accepts. And you'll quite often need that because there's no way to remember that for all functions. So that's the go-to place if you know the function name. If you don't know the function name, one good place to go to are the RStudio cheat sheets. For dplyr and for ggplot2, they quite nicely list the functions with an explanation, and you can of course search in them. So that's a good way to get the function names if you just remember the dplyr should be able to do that, but you don't remember which function it is. Lastly, there's Google. There are lots of online support forums. So if you have clarity on what you're looking for, you'll find the answer. And the support forums have lots of people who are willing to help and who are also quite quick. So if you come across something that's really not obvious, it's worth just posting a question, for example, on Stack Overflow. There are links to that in the document accompanying this. So those were the 10 areas you should understand to be set for the remainder of the course. Please have a look at the document under this link. It contains some more details and some more examples, and then bring your questions to class so that we can be set before we move on. See you then.